This is Geometry Chapter 2, Lesson 2.6, Proving Angles Congruent. The objective for today is to prove and apply theorems about angles. We started proofs in Lesson 2.5, and now we're going to prove some theorems so we can use them later on. So, you might be wondering what a theorem is. A theorem is a conjecture or statement that you prove true. So, we have this first theorem. It's a pretty big deal. It's called the vertical angles theorem. We abbreviate that often as VAT or VAT. It says that vertical angles are congruent. So in this diagram, angles 1 and 3, they're opposite each other in the x, so they're congruent. And angle 2 and 4, opposite of each other in the diagram, so they are also congruent. And so what we're going to do to start off with today is we're actually just going to prove that theorem. So to prove a theorem, we start off by kind of writing as an if-then conditional statement. The hypothesis becomes the given, and the conclusion is what we want to prove. And so that turns into this right here, our setup for our proof. It says angles 1 and 3 are vertical angles. Prove angles 1 is congruent to angle 3. So you want to think about it as if these are vertical, then they are congruent. And so we've supplied the statements. What we have to come up with are the reasons. Remember, this is our second day of proofs. So let's think about the first one. Angle 1 and angle 3 are vertical angles. I see that as a repetition of what they already gave me in the given. And if you remember, when you repeat the given, we have a reason that we get to use, and that is given. About 90% of the time, that's going to be your first line of your proof. Okay, then it moves on to talk about how angle 1 and angle 2 are supplementary, and angle 2 and angle 3 are supplementary. And we're going to talk about that. Being able to say that these two angles are supplementary, we want to look at the diagram and see how we know that. So we've got angle 1 here, and angle 2 is actually next to it, and they're connected. We call that when they're connected adjacent. And you might notice that also they share this straight line. So we talked about this a little bit in Chapter 1, but if we have two angles that are adjacent, meaning they're sharing the green line, and they make a straight angle, the blue line, that means that they're a linear pair. And so being able to say that these two things are supplementary for angles 1 and 2, and it's actually similar for angles 2 and 3 as well. You can see 2 and 3 share the red line, or they share the blue line, and together they make that straight red line. We can say that this is our linear pair postulate, or our LPP. If you're struggling with remembering that one, go practice the Quizlets. That's a big one. And so then all of a sudden we jump down to saying that these two angles we knew were supplementary add up to 180. And so remember that to be supplementary means two things add up to 180. And so 1 and 2 they're saying add up to 180, and 2 and 3 they're saying add up to 180. So we said there's basically four different ways you can, four different reasons you can give in a proof, different types. You have postulates, properties, definitions, and theorems. And this one would actually be a definition. It's the definition of being supplementary means two things add up to 180. And so that's how we would often get those equations set up. Now, we can see that they go, well, the measure of angle 1 and the measure of angle 2 equals the measure of angle 2 plus the measure of angle 3. So somehow we want to relate this statement 4 to what we saw in statement 3. I can see on the left side I have 1 and 2, and here I had 1 and 2. On the right side I have 2 and 3, and here I have 2 and 3. So somehow they took those two equations and they made them one equation. And that connection is actually usually what you see on one side. Since both of these things are equal to 180, they're both equal to the same thing, they must also be equal. This is one of our first 8 properties we talked about, substitution. So what they can do is they can say, well, since both of these equal 180, I can take 2 and 3 and I can go replace 180 with it. Okay. Now in this next one, we want to relate 5 back to 4. We see it has measure of angle 1 equals measure of angle 3. So what you want to identify is what changed, what's different. Well, I can even see it's even highlighted for us in red. 2 all of a sudden disappears. They just have 1 and 3. And so if you think about in an equation, if you wanted to get rid of that 2, you would subtract it from both sides. Well, that's exactly what they're doing. If they can subtract it off, and they get exactly what they get the measure of angle 1 equals the measure of angle 3, exactly what they wanted. But a lot of times kids want to stop at this step 5. Well, they'll say, oh, 1 is equal to 3. But actually what we want to get to is that 1 and 3 are congruent. So we go from an equal sign to a congruent symbol. This goes back to when we introduced congruence at the beginning, the definition of congruence. Definition of congruence is being equal. So if you can say two things are equal, you can say they're congruent. Once again, that's another definition. It's pulling on your vocabulary knowledge in use. And so we'll actually use that in some of the notes from 2.5 as well that we didn't finish. So we just proved the vertical angles theorem, that if two angles are vertical, they are congruent. And so what they actually did in here is they related both 2 and 1 to the, they related both 1 and 3 to this angle 2, and then they took it out to say that, hey, these things are congruent. And so now we're going to use it. It says using the vertical angle theorem, what is the value of x? We look, we've got an angle here and an angle there. They make that x, so they must be vertical. They're also congruent, which allows us to say that if they're congruent, well, this equals that. We get our equation, we solve it. I want you to try this one on your own and then check with me. You can check your solution with mine. I took that original equation and I just kind of continued to manipulate it and got x to be equal to 10.5. So what we want to do to practice though is talk about, well, how do we do all these steps? So the first one we want to think about, well, how did we get this equation? We got this equation from the picture. Because in the picture we had vertical angles. Well, that's your vertical angle theorem. Well, then you want to think, what do we do from the first line to the second line? I subtracted 2x. When you subtract the same thing, that's your subtraction property. Then you want to think, well, what happened between line 2 and line 3? Oh, they got rid of this 2 by dividing both sides. That's your division property. And technically, if this was a true proof, we would need this last line of switching this around to say, well, I want to say my variable first. So if you remember, that is your symmetric property. That allows you to switch the order. So what you are going to do now is you're going to solve this next one completely on your own, and you're going to justify each reason as you go. So this is, what is the value of x? Set up your equation, follow the one up above if you need to, pause the video, and try it on your own. Alright, you can check yours with mine. I got 2x plus 40 equals 3x is my equation. Vertical angle theorem, subtracted 2x from both sides, got 40 equals x. That was my subtraction property, and then I switched the order, x equals 40. That was my symmetric property. Alright, so we're going to prove some other theorems that are kind of useful. It says, prove using the vertical angle theorems. We are given angle 1 and 4 are congruent. Now, if that's not marked in my diagram, I'm typically going to go mark it. Okay, oops. That's not what I wanted to do. Angle 1 and 4 are congruent. That's what I wanted to do. 2 and 3 are congruent. That's our goal. So you can see they gave us the statements. We have to come up with the reasons. So angle 1 is congruent to angle 4. That's a repeat of our given. That's what I want to put. Angle 4 is congruent to angle 2. So this one, they're getting a little bit different. They've got angle 4 over here and angle 2 over there. Well, if you think about those, they're across from each other. They make that x. Those are vertical angles, which means that's our vertical angle theorem. Okay, now they jump to saying 1 and 2 are congruent. So I go find those. I've got 1 and I've got 2, and they're saying they're the same. Well, all I've said so far, if I go look at the other lines, I had 1 in here once and I had 2 in here once. And they are both in congruent statements with angle 4. And so typically we want to look at those lines above and how did we do these things? Well, originally it said 4 is congruent to 2, and they're replacing that 4 with a 1. They can replace that because of the statement above. They can replace that 4 with a 2, or with a 1, sorry, and bring it down. That's your substitution. We keep going, angle 1 is congruent to angle 3. Well, this is the first time they've talked about 3. So we go look at 3 in the diagram. We've got 1 still over here and 3 over there. And in the black, we can see they're across from each other. They make that x. Well, that's the same thing as we did in step 2. That's your vertical angle theorem. Now they jump down to this last statement saying 2 is congruent to 3. We look, 3 was the same in both lines, but 1 and 2 switched. So typically you want to go back and look at maybe the statement above. Here you had 1 and 2. Well, here you had a repeat of 1. They probably took that 1 since it was congruent to 2 and replaced it. That's once again our substitution property. If you replace something, you're using substitution. Now there are some other ways you could do this also using the transitive property, technically, for both of these lines. I would accept either of those. A lot of times they're interchangeable. Not always, but you could say transitive for step 3 and 5 as well. Alright, so we've got this next one. It's the same exact picture, but what we're trying to prove is different. So, we're given angle 1 and 2 are congruent this time. And we're trying to show that all of them are congruent. So we want to start our proof with our statement, angle 1 is congruent to angle 2. We always start with the given. Our reason is the given. Okay, now we want to think about, we're going to do this one pretty similar, I can't space it, to how we did the last one. Angle 1 is congruent to 2. Somehow we want to get angles 3 and 4 in the proof as well. Well, earlier we talked about vertical angles, so let's look for vertical angles. If I've got 1, I've also got 3, which is the same. And so I could, because they're vertical angles, so I could say angle 1 is congruent to angle 3 by the vertical angle theorem. Now what you want to think about in this line, is there anything else that's also congruent by the vertical angle theorem? Well, I've got 2 and 4. So maybe I say angle 2 is congruent to angle 4 as well. That would be a good start. Okay. Well, my goal is to say everything is congruent to everything. And so here's the thing. So far I've said 1 is congruent to 2 and 1 is congruent to 3. What I haven't said yet is that 1 is congruent to 4. So that's probably what I want to say next. I want to say 1 is congruent to everything. So somehow I want to get to say angle 1 is congruent to angle 4. So in order to do that, you want to look at all the lines that have a 1 and a 4. I've got a 1 here, and I've got a 4 here. I can see that both of those have this 2, and since they're both congruent to the same thing, I can skip that and say they're congruent to each other. You got 2 choices for how you can skip that thing in the middle. We used substitution property mostly last time. I'm probably going to use the transitive property this time. Okay, now that we've said 1 is congruent to 2, 1 is congruent to 3, and 1 is congruent to 4, well then they all have to be congruent, so now we can just make our long line. Now we link all these statements together, saying 1 is congruent to 2, 1 is congruent to 3, so those 2 and 3 must be congruent. We do all this using, once again, our transitive property. That's how we link stuff together. If 1 is congruent to all of them, they must all be congruent to each other. 2 things congruent to the same thing, they are congruent to each other. So far what we've been writing are 2-column proofs. It's not the only kind of proof we do though. We also write proofs in paragraph form. Basically each line we write it as a sentence and we just kind of keep going. And so we're going to see a repeat of that proof right here in paragraph form. So we started by saying angle 1 is congruent to angle 4 was given. Then we said angle 4 and 2 are vertical. Okay. Then we could say we use the transitive property that then link those 2 statements here together. Say 1 is congruent to 2. They've got a little bit of an extra step by adding in that 1 and 3 are congruent as vertical. In my proof, I combine that in the same step up here, and then by the transitive property, hey, 2 and 3 are also congruent. So that's kind of that was the first proof we did. It's just in paragraph form, writing full sentences. You can write a proof either way you want. I see a lot more 2-column proofs, but either way is just fine. So the vertical angle theorem is really helpful, and it has a special case, or it's a special case of this theorem right here. It's called the congruent supplements theorem. And so in our proofs, if you remember, we started by talking about how different angles were congruent and the same, we linked them together. And this kind of does a similar thing. It says if two angles are supplements of the same angle, then the two angles are congruent. So they're saying here that 1 and 3 add up to 180 and 2 and 3 add up to 180. Well, that means that 1 and 2 have to be the same. Okay, and we could have proved the vertical angle theorem using this idea as well, or not. So what we're going to do right now is we're actually going to prove this theorem. So it says angles 1 and 3 are supplementary, angle 2 and 3 are supplementary, prove that angle 1 is congruent to 2. So we're going to write it as a paragraph proof. So if we look back at our last paragraph proof, when they started their given, they just said whatever was in the given and said is given. So that's what we're going to do. We're going to start by saying angle 1 and angle 3 are supplementary, and angle 2 and angle 3 are supplementary is given. Okay, then we want to think about, okay, what does it mean to be supplementary? That means two things add up to 180. So that's what we're going to talk about next. We'll say, oh, the measure of angle 1 plus the measure of angle 3 is 180, and the measure of angle 2 plus the measure of angle 3 is 180. We talked about how we could do this earlier. That would be by the definition of supplementary. Now, if you remember back to some of our earlier proofs, like what we did back a little farther, here in our vertical angle theorem proof, once we said two definitions supplementary, things add up to 180, we linked them together using the substitution property. That's probably what we want to do on this one. So, sorry about that, my board took off on me. So we said they're supplementary, and we probably want to link them together using these 180s to say, hey, these two things are the same. The measure of angle 1 plus the measure of angle 3 equals the measure of angle 2 plus the measure of angle 3. We talked about how that's by the substitution property. Okay, so remember, our goal is to show that 1 and 2 are congruent. So somehow we've got this equation right here. We want to somehow get that to 1 being congruent to 2. Well, if 1 is congruent to 2, you can also talk about how 1 is equal to 2. And if you look in this equation, we've got a 1, we've got a 2, and they both have this 3. So maybe we get rid of that 3. It's on both sides. You can subtract it from both sides. So we're going to say the measure of angle 1, and we're going to get rid of that measure of angle 3, equals the measure of angle 2 by the subtraction property. I subtracted it from both sides. A lot of people want to end here, but you technically can't end here, because the goal is to say angle 1 is congruent to angle 2. We did a problem like this already where we linked an equality to a congruence. How do you go from equality to congruence? That's your definition of congruence. Okay, so we did a paragraph proof. I just did a sentence each line. Typically, you'd kind of put all of them actually in a paragraph, but you can do it kind of either way. We have 3 big theorems here at the end that are very similar to what we just talked about and kind of common sense. We just did the congruent supplements theorem. We have a congruent complements theorem. 2 angles complementary with the same angle, they're congruent. So 1 and 2 are complementary, 3 and 2 are complementary, 1 and 3 are the same. This one is called the right angle congruence. You got to put that name in. Basically, it says all right angles are congruent, which should make sense. They're all 90, they should all be the same. Then this one kind of builds off of the congruent right angle congruence thing. It says if angle 1 is congruent to angle 2 and angle 1 and 2 are supplements, well then they're both right angles. We call this the right supplementary theorem. Right supplements theorem. That one's also a big deal. Some common sense theorems. All right, and that is the end of lesson 2-6 of geometry.